but it's essentially this format where you kind of grab stuff from the matrix and set it equal to each other. Right, so let me grab number 9 and we'll take a look at that. All right, so this one's a little bit more intuitive. If you look at just the first row of all of this right here, just the first row, I think you can see this pretty well. It's really -3 plus minus x minus a -2 equals -21. Just rewriting that first row there.
Mm-hmm. All right.
And we don't have to know why, we're just going to do it. We're trying to get through this and we'll figure out the why later. Now, this is a lot like the previous one, so I'd like you to try solving it from here, please. How are you doing on this one?
Good, I'm almost done.
Great.
And oh, wait 1 second, I'm not done yet. I forgot one thing. X equals +20.
Okay, now we're gonna do the same thing for the second row here. All right, second row is 5 plus -5y plus 7 minus a -10 equals -4y minus 1. So this one looks more complicated. It's got more stuff going on. With all the white space, it's maybe a little bit cumbersome right now to look at. So we're just going to kind of work it a little better. 5 plus -5y plus 7 plus 10. So those two negatives become a positive equals -4y minus 1. All right, so just kind of condensing it, making it more readable. Now you do combine like terms. So on the left here, you've got a 5, a +7, and a +10. Those combine to make 22. Okay. And then we're going to solve from here. So to do that, I'm going to add 4y to both sides. So you have -1y plus 22 equals -1. Subtract 22 from both sides. That leaves you with -1y equals -23. And then divide by -1. So y equals 23.
All right.
Any questions before we move on to apply your knowledge?
Nope, I'm good.
All right. So the instructor gives you kind of this preamble here. It says the first matrix belongs to the cost of 1 dozen eggs and oranges in 3 different markets. And W2 is the same cost, is the cost of those same items, but in another week. All right. And I mean, we don't really need to know all that, but it's an apply your knowledge problem. So it's some sort of application to real life. We know that eggs are way more expensive than that. If you haven't looked, it's sort of shocking, but nevertheless, that is the problem here. So it asks you to find W2 minus W1. So here is W2, okay? And then we're going to subtract W1, which is the top matrix. Okay, and what this will reveal is the difference in price between the 2 weeks. So the steps here are to, I'm going to make this bigger, is you take that top left number 0.97 from one on the left there and subtract 0.97, and that equals 0. So notice there's no difference in price. Then you go to the 0.85 and subtract 0.90, that's minus 0.05. So what that means is they're actually less expensive than the previous week. And then the third number on the top, 1.05, subtract 0.95 to get 0.1.
Okay.
Okay, and then we do the same thing for that bottom row there. We're going to take that 1.49 and subtract 1.99, and that's minus 0.5. 1.79 on the left there, subtract 1.79 on the right. That's 0. And then the last one, 1.89, one is minus 1.59 is 0.3. Okay. And this is showing your work, but the answer just requires the outputs. So 0, negative 0.05, 0.1, minus 0.5, 0, and 0.3. This is the result. So you're literally just subtracting. Like it probably feels like there's a complicated thing. You just subtracting, no big deal.
Yeah. Okay.
All right, that's part one. You'll notice there's a single I there. Part two coming up here. It's based on the results, so I'm going to snip that in. Part two, it says, for which market was the change in price of oranges the greatest? So oranges are on the second row. So we're looking at these three numbers, and you're trying to decide which had the biggest change. And the biggest change was in market one. Even though it's negative, change could be up or down. And so it's that minus 0.5, which is in market one. Market one is the first column.
Got it.
Now it says, what was the change in price? You would say it went down by, and you want to use the correct notation here, dollar symbol 0.50. That's what the negative means. We usually don't use negatives, and with money we talk about it going up or going down. And then lastly, you have to sort of point to that one and say it's that one, where it says indicate the entry value that tells that.
Mm-hmm. Okay.
Okay. So as quickly as you can, I know you like to deal with the submissions. I'll get the naked problem set going, but be good to just move on to it. Maybe do those at the end.
Okay.
So let's take. All right. So stop and think. Stop and think. Okay. All right. So the first question here is a multiplication problem. It says multiply and show the steps. So the show the steps is kind of the painful part here. You have to show that you're going to multiply each of these numbers by minus 14. So it's a lot of writing. It's minus 14 times minus 8. leave a little white space, minus 14 times minus 20, minus 14 times 13, minus 14 times minus 15. This is what they mean by showing the steps. They want to actually see that you're showing the multiplication. You don't have to work it out longhand. You can go to the calculator. So you're going to want to multiply these numbers together.
Okay. Sorry, just give me 1 second. I'm just trying to get caught up.
Yeah.
Okay, now I'm just gonna put these in Desmos and yeah. Okay, so so some of the answers should be 112,
Yep.
280, negative
Good.
182, and 210.
Good. Now, what you want to do is show your answer where there's kind of like white space between the numbers, like to show gaps. That's just like up here. So if you're a big writer, or if you're, you want to be, you don't want the things to merge together.
Yeah.
Right. All right. So number 2 here. Number 2 is really, really similar. Again, unfortunately, you've got to show the step, which means literally showing. You have to literally show multiplying each of these by that number.
Okay.
So you want to give yourself plenty of room here. 15 times negative 20, 15 times 12, 15 times negative 7, 15 times negative 12, 15 times 14, 15 times 15, 15 times 1, 15 times 0.
Okay. Give me 1 second, please. Okay, I got everything. So the first one is negative 300. The second one is positive 180. The third one's negative 105.
Good.
Uh,
Keep going.
the the next one's negative 180. On the bottom row, it's 210, 225, 15, and 0.
Okay. So let's keep moving here. All right, so we did this a bunch yesterday, and a quick review here. So we first have to determine to do a problem like this. Uh, we have to first determine the size of the matrix or the dimensions. So I talked about this idea of circling, and we're starting out with rows. How many rows does this one have?
4.
4. And then how many columns does it have?
2.
4 by 2. Okay. Now the one on the right here, how many rows does it have?
Just 2.
And how many columns does it have?
Just 1.
Okay. Now this is important. The following, for you to be able to multiply matrices, the inner dimensions have to match.
Mm-hmm.
So the first thing that it asks for is the dimension. So you want to write this down for dimensions. That's answering that part. It then says, can they be multiplied? And if the inner dimensions match, then yes. Okay, so in this case, yes, they can be multiplied, and it's because the inner dimensions match.
Okay.
All right. So number 4 is kind of the same question here. So what I'd like you to do very quickly is tell me the dimensions of the first matrix here.
It's 3 rows. Sorry.
Yeah,
Yeah,
3 rows. I
3 by
I
1.
agree. Okay. And then the other one is 1 row and 2 columns. So that's the dimensions. Can they be multiplied? If the inner dimensions match, then yes, they can.
Yeah, they can be multiplied.
Yes. All right. Um, okay, so number 5 is really similar to what we've already done here. It's a multiplication. You got to show your work. So you have to show multiplying every single thing by minus 15. So it's a lot of writing and then a lot of calculating.
Fun.
Yeah, so what I'd like you to do is write it down and do the calculations later. We can come back to this if we have time. Because the next few problems do have more work involved in them, and I don't want to miss out here on getting this done, because we know how long it can take to get these things graded. So move on to 6 here. Go back and multiply that later. All right, so 6. We looked at a problem like this in 3. You can multiply these, and this is where it's most awkward. So the dimensions are 4 by 2, and then it's a 2 by 1. So your resultant answer is a 4 by 1. So because the inner ones match, you can multiply these, and the dimension of the new matrix is 4 by 1. 4 rows, 1 column. So our answer is 4 rows and 1 column. So some books use this notation to indicate the position. E 1, 1 means row 1, column 1, row 2, column 2, E3, 1, third row, or first column, E4, 1. All right, so this is kind of our setup. I know this looks confusing, but we're gonna dial it in here in a moment. So to find E11, that's what we're gonna do first here. You take the first row and multiply it by the first column. So E11 is -5 times -13 plus 9 times 2. All right, so we want to maybe grab a calculator. Should get 83.
Yeah.
Okay. Now so that 83 is the first number in your answer. Okay, that's the first number in your answer. The second number, E21, you take the second row and multiply by the first column. -16 times -13 plus 14 times 2. And this equals 236. And then similarly, we do the same thing here with the third row. Take the third row by the first column, E31, -7 times -13 plus 20 times 2 ends up equaling 131. All right. And then finally, for the last one there, we go fourth row times the first column, E41, is 15 times -13 plus 0 times 2. That's -195. So when it says show your work, that's what it means here.
Okay.
Now, good news is that's the longest one of them all, but that's pretty long. A lot of when you have to show your work, it's a lot of steps. So the actual answer is what's up here, top right, but you have to show these calculations. So let me know if you need to get any of those. They'll also be in the notes at the end as well.
Okay.
All right, you ready for the next one?
Mm-hmm.
Okay, so number 7 here. Number 7 here, you have 3 rows and 1 column. And then the other one is 1 row and 2 columns. So because these match, okay, the 3 by 2, the 3 rows and 2 columns is your answer. So it's going to have 6 entries: E 11, E21, E31, E12, E22, E32. So our answer is 3 rows and 2 columns, and we have to come up with that. We have to come up with those numbers. All right, so we're gonna take this matrix each time and get the result here. So it's kind of a tedious process here, but E11 means to take the first row times the first column.
Okay.
And then E12 means to take the first row times the second column. So let me get to a place here where I can give you the correct answers or check yours as we go. Let me that times bracket. And nobody does this by hand, but that is you have to do it by hand here, and then maybe later on you get another option. So I actually messed up already. 16 minus 15, 19, 2. There we go. This first one is actually 304. That's why it's always good to check me. 304, and this one is 32. Good. Okay. So those are the first two entries. All right, now we're going to do the next two. We're going to get this E21 and E22. So E21 means to take the second row times the first column, minus 15 times 19. And then E22 means to take the second row times the second column, minus 15 times 2. And this becomes minus 285 and minus 30. And then similarly, to find E31, you take the third row times the first column, 15 times 19. And then to find the E32, the third row and the second column, 15 times 2. This ends up being 285 and 30.
Okay.
All right, so the final answer, final answer is got those 6 numbers in it. It's got the 304, 32, minus 285, minus 30, 285, and 30, like that.
Okay.
All right, so number 8, make sure you get all this down. I mean, your instructor may, we don't want him to bounce back for lack of work, but it's all here. These are checked in the computer, so I'm not pretty sure these are all right, but we'll do a double checker at the end as well.
Okay.
Okay. So here we go. Next problem here, number 8. So the first matrix is 2 rows by 1 column. And then the 9 minus 10 is 1 row by 2 columns. So these match, that's good. And so our answer is a 2 by 2. 2 by 2. So you got E11, first row, first column, E21, second row, first column, E12, first row, second column, E22, second row, second column. Now you
Okay.
can almost do this one without it's because this first one is E11 is 6 times 9. This really is the first one that we should have done. So it's really 6 times 9 in that first position. First row, first column. And then E12 is 6 times minus 10. It's almost like the distributed. It's like, all right, I give this to this, and then I give this to this.
Yeah.
And then for the next row, you take this minus 9 to 9. Then you take the minus 9 to minus 10. Okay.
Okay.
So go ahead and multiply those out. Let me know what you come up with.
Okay, you get 54, -60, -81, and 90.
Correct. Good. Okay. Really good. So that is number 8. Number 9. It's like one more of these things. Good news is we will be able to finish this today, barring something catastrophic happening. So we're in really good shape here. 9 is we've got a 1 row by 2 column to start. That's the first one on the left, 1 row, 2 columns. And then this one on the right is 2 rows, but 3 columns. All right, so what that means, since the inner dimensions match, the outer dimensions tell you your answer. It's 1 row, but 3 columns. E11, E12, E13.
Right.
So we'll space this one out a little bit just to make it a little bit more clear. So to find E11, you have to take the first row times the first column.
Okay.
-4, -17. I'm sorry, that's not right. -4 times 6 plus -17 times 19.
Okay.
Then you do the same thing to find E12. You take the first row times the second column. -4 times 10, -17 times 11. I'll get those results numbers here shortly, but same thing here for the last one here. You find E13, take the first row times the third column, -4 times -13, plus -17 times 5, like that. All right. So I'm going to go ahead and grab these results. And that's 13, 19, 11, 5. All right. Again, you should probably double check me, but I'll give you some numbers here. This is minus 347, minus 227, and minus 33. So your final answer looks like minus 347, minus 227, minus 33, like that.
Okay.
Okay. Apply your knowledge. Apply your knowledge here. So let me go ahead and snip this in. Here we go. The matrix D gives the delivery of cases of 4 bakery products to 2 restaurants. So there's Pierre's and Pauline's restaurants, wheat bread, white bread, rye bread, English muffins, and then there's the cost. There's the cost of wheat bread, white bread, and rye bread, and English muffins. And so they're trying to show you that if you were to multiply these together, you would get the cost of, like, for example, wheat bread to Pierre's, or rye bread to Pauline's. You could get any sort of these numbers here. And so that is part A. Part A is to do yet again, another multiplication here. All right, it's to do D times C. All right, so I'm going to snip those in here. D is the quantity matrix. This is D. And notice D is a 2 row by 4 column. And then you're multiplying by a 4 row by 1 column. This first one is D, the second one is C. The inner dimensions match. So your result is a 2-row by 1 column. E11, E21. 2 rows, 1 column. All right, so unfortunately, we just have to do this, yet again, do these multiplications here, but we're getting fast. We're getting faster. So let me I'll kind of frame this here a little bit. So E11, to get E11, you take the first row and multiply it by the first column. So that's 5 times 7 plus 10 times 7 plus 3 times 6.5 plus 5 times 8. And then to get E12, same thing. You have to go, sorry, E21, that wrong, E21. Second row, first column. 0 times 7 plus 15 times 7 plus 8 times 6.5 plus 10 times 8.
Mhm.
All right. And then just because I don't want to have any calculation errors, I'm going to use the computer here. You can go to calculator if you want there, but we're going to multiply these together. 7, 7, 6.5, and 8. Okay, so the first one I get 164.5. For the second one, it's 237.
Okay.
Right, so that the answer here is 164.5, 237, like that. That's part A.
All right.
Part B is to find the daily cost of the products at Pierre's. And so Pierre's is the first one. Pauline's is the second. So it's $164.50. You're just grabbing that number right there.
Mm-hmm.
The cost of Pauline's is $237. It's more because they have more of the more expensive breads, I suppose you could say. All right. And then from here, we can do part C. Okay, so it says they're open 20 days a month. Pauline's is open 25 days a month. Find the total cost together of these bakery items for the month at the 2 restaurants. So hint, take matrix M, 20, 25, and multiply it by the answer from above, which is, well, I'll just go and grab it here. So this is a 1-row by 2 column, and this is a 2-row by 1 column. Since the inner dimensions match, the answer is a 1-row, 1 column. So just one number. You take this row, first row, times this column. So E11 is 20 times 164.5 plus 25 times 237. And that
Okay.
gives you one number. And so the idea is if you had, let's just say you had a bunch of stores, you could do the calculation relatively quickly because you would just extend these matrices with the number of stores and you wouldn't have to redo all the calculations by hand. But that looks to be $9,215.
Oh, wow.
So with the time we have left, I know you've got to get this one down, but with the time we have left, it might be good to look over any of these to see if there's anything you think you missed, didn't write down, or ones you think we should check again.
Don't we have to do number 5?
I'm sorry. Yeah, 5 still needs to be done. I'm just you can for sure do that on your own. I'm happy to do it, but let's see here. Yeah, way back here. There it is. Yeah. So yeah, I mean, you can do that real quick if you want. With the time we have left, I'll check your answer.
Okay, so here's what I got. Negative 165, 60, negative 90, 210, negative 30, 75, negative 60, 180, and negative 120.
Good. There you go. You got it.
Right.
All right. We're going to go ahead and stop right there.